Okay, guys, now let's discuss about the third practical exercise. So, our third practical exercise will be this. So, let me go to the practicals. Here is practical sessions over there. The third exercise is land cover change detection using the remote sensing glimpse. So, here actually I provided you some like two different Landsat images. Here I mentioned like 2018 and 2023, but the actual images are like from 2017 and 2024. It's like already classified image, not a pure Landsat image. Previous practical exercises I discussed how we can do the classification part. So this is the final output, like the already classified image, and then how we can get a rough estimation. Okay, in 2000, as this example, like in 2018 we do have this much of crop area. Okay, like rice cultivated in this much area, like how many hectares, and then in 2024 it has been converted into like build up areas. So some people will like build their houses or something, so they are to cultivate like for their own interest. So likewise, we can check like how many forest cover has been changed. So we can give a rough estimation using a satellite data. So here, what we are going to do is we are going to detect how many uh, hectares of cropland has been converted into the build-up areas in 2023. So that's the simple thing. So let's go into the practical exercise. Same thing here. Download your information, download your data file. So I already downloaded the data file in here in the practical 3. So here we do have the classification, two classification rasters and one district shape file. So let me go ahead and like open up the arc map for you. So out of all the practical exercises, this is the easiest one. The rest of the practical exercises will take bit time and it's like a little bit hard. Okay, let me close this one and open a new file. Let me create a geodatabase. You know the drill. Just follow the same steps that we have followed till now. So first we need to create the geodatabase, and then we have to save the project file, and then start doing your analysis by using the tools in the toolbox of Arc Map. Over there, my files are in D, practical 3, click OK, click new geodatabase. We'll replace this one as X03, add a file X03, save. Okay, now we are here. Go to the catalog, load the data files, 2017 classification, drag and drop, 2024 classification, drag and drop, and then district shape file, drag and drop. So here in these exercises where we are going to do this analysis is for Gampaha. So what's the main thing that we have to do? We have to clip the Gampaha from this the Sri Lanka district shapefile. So how we can like clip this one? Right click, open the attribute table, select Gampaha, and like right click and zoom to Gampaha district, and then go to search for clip analysis district, and then clip features district. This one will be Gampaha district. Description file and click OK. Take a while to clip out the Gampaha from the entire Sri Lankan shapefile. So now Gampaha district has been cut out from the entire Sri Lankan shapefile. I will remove the entire Sri Lankan shapefile. Now next thing is we need to clip these two rasters into Gampaha district, because we are going to do the analysis only to Gampaha district. So I will go for the clip, same tool, data management, input raster, 2024 classification, output processing extent, Gampaha district, same, and then this one will be Gampaha LC 2024.tif. Okay. Okay, now same thing, data management for 2017, output processing extent, Gampaha district, same here. This one will be Gampaha LC 2017. Okay. Okay, after that, what I can do, I can take this one to view the shapefile, and then I will remove these unnecessary shapefiles from here. So this is Gampaha district LULC classification in 2017, and this is LULC classification 2024. So if you didn't see the files like this in your ArcMap, what you have to do is right click on this layer, go to properties, and then click on unique values, and then click OK. That's all. Same, right click on properties, and then unique values. Under the symbology, click on unique values, click OK. So now you will be confused, like what the heck is like this 1, 2, 3, 4, 5, 6, and 11. You don't know what. So actually those are the classes. If you go into the table, you will see, if you see number 1, that means water bodies, and if you see number 2, that means trees, and if you see number 4, is like flooded vegetation. If you see number 5, is croplands. If you see number 7, is build up areas. If you see number 8, is bare lands. If you see number 10, is like cloud covers, and if you see number 11, it will be rangeland. So how we can like change the color ramp? Right now you cannot like understand what the heck is going on. So we just need to let me like zoom in and like show you a very first very important point. If I zoom in, and zoom in. So this is 1 pixel. So it should be 10 by 10, because we use Landsat, not Landsat, Sentinel 2 dataset. So you can see the measurement of that segment is 10 meters. If you see here closely, you will see the measurement is 10 meters. So the time, like the one cell, one pixel is 10 by 10 meters. You just keep it in your mind. So how many square meters this one tile is representing? 10 by 10, 100 square meters. So now let's change the color ramp into a much more user friendly color ramp. So how we can change the color ramp? Go to the properties and then click on this one and change the label. So get the values from here. Water, one is water, and then copy this color hex code. If you need to apply the color hex code, just copy the color hex code, click on the color in here, and then more colors. From color, choose RGB, CMYK. Or you can put the color hex code in here. Click on advanced selection, CMYK. You have to type this one. So let me wait the windows. Click the window. So let me go to the catalog, database, refresh, compile USD. I think I removed 2017. I will load that thing, and then zoom to layer, right click, properties. Let me label this one first, water. Then trees, colored vegetation, crop, number 7, build up area, ground of your lands, number 10, clouds, and then 11, French lands. Now for the color, click here, more colors, colors, on RGB, instead of this one I will select the colors. For water we can give the green color, and then for the trees we can give a yellow color and then the green color. Then for the flooded vegetation, we can select a lighter color, and then croplands we can select yellow color, and then for build up areas, of course, we can use red colors. Bare ground we can use some sort of pink color, and for the clouds we can use white, and then for the rangelands we can use some sort of ash color. So let me export this color ramp, and then paste this in here, and then click apply. Okay. Then same thing for this one. Let me go to the properties, and then color map, import color map, click on this one. Okay. Now you see colors has been applied automatically. You don't need to worry. I just need to copy these values here. Water, then trees, colored vegetation, then crops, then build up areas, then bare grounds, and then clouds, and then rangelands. Click apply. Okay. Now let me put the 2017 on the top. So here you can see 2017 is in the top, and the white color area is like the crop lands. And then I turn this on off and look closely, you can see definitely some of the bare lands has been converted into the build up areas due to some reasons. So now we need to calculate. So if you closely pay your attention in here, this region, if you pay your attention to this specific region, this is like 2024. Here, just close your attention in here, and if I turn this one on, you can see there's a change in the build up areas. Even in here, if you pay the attention, in 2017 it was like much bigger, upland was much bigger, but when it comes to 2024 it has been reduced. So how we can do a calculation like this? Now we do have the two layer files, and now we need to do a calculation. So for the calculation, before we go for the calculation, you need to understand about these codes. If you go to the properties, you will see here actual value codes. So for the crops, number is number 5. For the build up area, the value or the code is number 7. So for this one, we can go to the search and search for the tool called Raster Calculator. So open up the Raster Calculator. Here we have to type a logic, that means condition. So condition, what is the condition? We have to type Gampaha LULC TIFF, that means from the TIFF file. If it is equal 5, that means what? Select in 2017, select the crop lands. Number 5 means crop lands, and then select Gampaha LULC. From the Gampaha LULC TIFF 2024, select class 7, that means build up area. And then is like we are going with the AND command, that means do the differentiation part. If both commands are satisfying, then 1, that means there's a change. If not, it is 0. So 1 represent the areas with the change, and 0 represent the areas with no change. So it's like if the condition is true, is true. If else is false. It's like you guys are like from ID, you know. So now we have to type that condition. So con, I will open up a bracket, 2017, then equals number 5 for vegetation, then close the bracket and open a bracket, Gampaha LULC 2024 equals number 7, close the bracket, and then after the comma it should be 1. If it is false, it should be 0, and then this one is the calculation, simple calculation. So we can give it the raster name crop to build up change. So you guys need to practice. So if you need to check how many forested areas has been converted into the build up areas, how we can do the calculation, how we need to change the equation, you need to understand how we can change this equation. So Gampaha LULC, at the beginning it was trees, so 2, and then Gampaha LULC 7 converted into the build up area, same. So likewise you can change the other conditions as well. If like water resource has been abundant, or like the tank is abundant, how many tanks are abundant in Sri Lanka, you can do a calculation. How you can do the calculation? Same equation. So I will type the crops to build up change and click OK. After that, what should I see? I should see one single raster with values of zeros and ones. So now you see this one. So what does it mean? All the black color ones, maybe your color is different. If you see black color, that means there's no any change. And if you see the other color, the number one, the color of the number one, let me zoom into this area. You can see there's a green color. If I turn this one off, you can see in 2017 we had a cropland in here. If I turn it off, you can see it has been converted into an build up area. Same thing goes. So if you zoom into the other regions as well, which was identified here for an example here. So if I turn it off, in 2017 it was a cropland, and then in 2024 it has been converted into a what? It has been converted into a build up area. So let me zoom to this one and then check the pixel should be 10, because why I am saying this one multiple times, because you need to we are going for calculation. So it's like 10 meters, this side also is 10 meters. So 10 meters by 10 meters is 100 square meters. Now we do have these two classes. So if I go there and let me zoom to the layer and right click and open up the attribute table, here you see the count. That means how many pixels are there in this raster. So now you know 1 pixel represent 100 square meters. So in the simple maths, you can say it is like Sentinel 2, so it is like 10 meter resolution, since it can be like 100 square meters. So 1000 square meters is equal to 1 hectare. So if we need to get the hectares, how we need to calculate? Amount of pixel multiplied by 100, we get number of square meters, and then if we need to get the hectares, we have to divide it by 10,000. So now we need to do this calculation in this attribute table. How we can do the calculation? Click on this small button in here, table of option. Click on add field. Type in here. You can type the area. I will type area, and then for this one you can type double. Since the values can be decimal values, I will click double and click OK. Now click over there, right click, field calculator, yes. So how we need to calculate? Count, that means the number of pixels, multiply by 100, and then the entire thing, I will put a bracket to the entire thing, and then divide it by 10,000. We have divided by 10,000 and click OK. Then you get the area. So how many hectares has been changed? 1,992 hectares has been converted into build-up areas in 2024. So that's how you can do this analysis, and then how you can like visualize this one. So the visualization part, I previously discussed how we can visualize. So zoom to this layer, so you can type a simple sentence for the analysis. You can type a simple sentence. So here you can say, for the statistical report, you can say the analysis revealed that 1992.77 hectares of agricultural land were lost to urbanization of the Gampaha District between 2017 and 2014. So for the change detection map, how we can do the symbolization? Just go over there and then click on properties, and then you can go to the symbology, and then you can give the color. Either you can keep this value in white color, or you can keep the value in dark color, so the change will be visible. And then for this green color value, I will put this one in red and click on apply, so everyone can see how the change has been occurred. So here I will put a ash color, click OK. So these areas the change has been occurred. And now you can go to the layout view and insert a title, legend, north arrow, and then you also can export the map. So I think I don't need to repeat that part. You know how to do it. Go to the layer, import the map, right click, go to the properties, and then grids, new grid, measure grid, or reticular, next, 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 finish. Go to the properties, labels, I will set the time, the size to 12, OK, and then grid lines. For the intervals, I will say 5, 5, 0, click apply, OK, and then this style, I will select this style and click OK, apply. Yeah, I think I have to go to properties again and adjust the intervals, 0, 0, 5, 5, apply, OK, apply, OK, and then now at the north arrow, insert north arrow, click over there, OK, zoom it a bit, north arrow somewhere, and then insert silver, properties, click on kilometers, we will make the label as km, apply, OK. So go to the properties again, typology, because I need to set the font size to 12, OK, apply, OK, OK, we get the scale bar, and then can even resize it, and then insert title, and 24. Okay, then even I can add a legend. Properties, select a font, give it a apply, okay. How we can change the label in here? Go to properties, and then symbology, give the value. 0 means no change, and then areas with I. Okay, voila, done. So how we can export this one? File, export map, practical 3, fact03 EPNG. API typically we will need to put like 800 or 600 and then click save. If I go back into the practical 3 location, I will see a PNG file. So the map is there. And then for the report, what we can do, we can put a sentence in here. Sentence, how I can put insert text. So click this one. Value I know. 19.7 hectares of agricultural land lost. 2024. Font size I select 12. I. Okay, and then I. Okay. That's it. So if I need to export, I can go to the export map. Yes. This is the map. So even you can see the areas with the change. So you can do this kind of analysis for your final year thesis, if you have to do a thesis, you can do the simple analysis like this. Like, deforestation is going on over there in Sri Lanka, and agricultural land is losing because everyone is going after uh, becoming a doctors, software engineer or someone. No one is focusing on agriculture. So all the agricultural lands are going away, and even the water bodies are disappearing. Some of the lakes now we didn't even see. So you can do this kind of analysis if you are doing like environmental sustainability or focusing onto that field, and do this kind of analysis. So that's it for the practical 3. I will see you with the practical number 2.